All right, now this is Mr. Goodfellow, and they gave me the very last day, day number 6. So we are going to try our best to put together all of the possibly worst things that could possibly happen in radicals in this very last day. So it's a lot of more dividing radicals, but like what kind of things are you going to run across and what kind of methods could be really super helpful for you? Now, the very first thing I want to say when it comes to simplifying radical expressions in general, you have to be a person that ultimately doesn't want to give up until you have achieved all of the goals that are necessary, like not having a denominator with a radical in it, making sure that you've taken out as much as possibly can be taken out of every single radical. So a couple of things we're going to make sure that you definitely take care of. So we don't want any radicals, no radical in the denominator. Okay, that is not allowed. We can't have any of that stuff taken care of. We got to make sure it's all gone. Number 2, make sure that your radicals on the inside are as small or simplified as much as they possibly can. So you try and simplify them as much as they can. If it's a relatively big number in there, it should make you nervous because you want to break it down and see if there's numbers that are inside there. And then number 3, you want to make sure that you cancel top to bottom things that can be canceled. And remember that you can only cancel things that are on the outside of the radical, or if you have radical stuff that can be canceled, we'll try to identify that too as well. So only cancel, and I'd be basically focusing on outside numbers. That's really the focus here. Now, those 3 ideas right there, you have to be really diligent about how you actually are going to go after those things. And if you're really diligent about it, you have to be, in my opinion, a rabid chihuahua to go after this. Now, you can say you don't have to do this, but wait. You have to do it because you're a rabid chihuahua, all right? So you got to be able to bite into a problem and not let it go because you are mean. Look at the eyes on this thing. You're mean like this guy, and you don't want to give up on a problem until it is absolutely done. So keep this face in mind right here. Rabid chihuahua, rah! Okay? That's how you want to attack these kind of problems. All right, now in each one of these, I'm going to outline some techniques that can be really super helpful when it comes to radical combinations like this. First off, the first thing I would say is if you've got 2 individual radicals like this, instead of just multiplying the top and bottom by 54 to rationalize the denominator, sometimes you might run across radicals that are right out of the gate before they get even too big, that they can be simplified because they're perfect squares right out of the gate. Now, this tends, in most cases, to make the problem a little bit easier. So that upstairs piece is automatically going to be the number 6, which is way easier to deal with than the square root of 36. Now, the number 54, too, as well, it can be broken down a little bit, too, as well. It's 9 times 6, and that 9 times 6 has got a pair of 3s in it right here. You can see the pair of 3s that are going to be able to escape out of there. That's that perfect square in there. And if they make it out of the radical, we'd have something like 3 square root 6. Now, all I've done there was evaluate a couple of radicals that were really super close to being just simplified values. And that actually made the problem considerably easier. Okay, now there's a couple of routes you could still go from here. You could be like, I still have a radical on the bottom, or I could try and find some stuff that actually cancels. I see the 6 and this 3, and they cancel out pretty easily. So I could simplify this. There's not any way that these one coincides before the other. So you could really say that 6 and 3 might cancel down to a 2 and a square root of 6. Now look at that. We've actually really made this problem really not so bad now just by evaluating a couple of radicals and simplifying them in the beginning. Now, if I multiply each one of these by the square root of 6, both top and bottom, which is the rationalization method to get that radical on the bottom becomes the square root of 36, and the top becomes the square root of 2 square root 6. Can't multiply those. Outsides multiply outsides, and insides multiply insides, so those don't go together. And then the square root of 36 becomes the number 6. 2 root 6 over 6. And again, rabid chihuahua, I got to be mean and make sure that I get all of the final cancellations, and this 2 and this 6 will reduce to the square root of 6 over 3. Now, there isn't anything in there. The denominator doesn't have a radical. The top is small and concise and doesn't have any extra pairs. That is the simplified radical that we're looking for that dividing deal. And I took care of that problem by having a rabid chihuahua attitude about it. I'm going to get this thing. All right. Now, the same kind of premise can happen in several of these other problems that are down the way. This one was 2 separated square roots. If you happen to have them all underneath one singular house, it's okay to separate them under 2 separate houses like this. And I did that on purpose because the square root of 64, again, is one of those numbers that can be broken down relatively easily. We're like, oh, that's an 8, and the bottom is got a 4 and a 7, and the 4 is a pair of 2s, so that would be 2 square root 7. Now, all I did was separate the house and then make it turn into 2 easier radicals that I could actually do the problem with. So you can separate houses or put houses together. It doesn't matter. I just think that's probably the easier way to go. Now, the 8 and the 2, you could simplify these to make it 4 over the square root of 7, because I'm just simplifying this concept. And then I have to rationalize the denominator again with the square root of 7, because I'm not allowed to have that radical downstairs. And I've got 4 root 7 over 7. And you box that answer up and be like, okay, the inside is as simplified as possible. The outsides can't cancel. Yes, I bit that problem and shook it until it was absolutely done. All right. Now, they can tend to get to be a little bit cumbersome as you get along. Specifically, cubed roots can kind of be a nightmare. I would not want to triple root this by a 54 and a 54 to just complete the 54. So what I would suggest you would do on this one is let's leave the 4/5 alone, and then let's see if there's some way I could write the entire thing as the cubed root of 18 over 54. So be like, maybe those two together would work better as a fraction together. And it turns out that 18 does go into 54, and this whole entire thing would turn out to be 4/5 times the cubed root of 1/3. 18/54 reduces to 1/3. Now, I've just made the problem smaller, which is really a good idea. And now I can separate the house back into 2 separate houses. 4/5 is going to be multiplied by the cubed root of 1 over the cubed root of 3. And the cubed root of 1 is just the number 1. So I think that's going to be okay. Now we've got 4 over 5 to the cubed root of 3. Okay, now that cubed root of 3 is still a big problem down the bottom. And we discussed this in the past about how I'm going to rationalize a denominator like that. Well, this cubed root of 3 is looking for a group of 3, but there's only one 3 that's inside there. So he needs a partnership of this cubed root of 2 more 3s. That's 1, 2, 3 of them to complete the cycle of 3 to get him to come out. Now that's the cubed root of 3 squared up there. Now, I know this, you're like, wow, this has got a lot of tools to it. You got to just be really going after it. That's a cubed root of 9. That's what 3 squared is. And that's over 5 times. And this completed the group of 3 that you needed to be able to get them to come out. That'd be 5 times 3, or 4 third root of 9 over 15. Yuck. That is really not the most fun problem. And cubed roots can have a tendency to be one of the harder kinds of questions that you might run into. Okay? Now, let's go down to some of these lower ones and see what we can actually come up with. Now, some teachers will tell you that you need to multiply by the entire root, like 3 root 2, both top and bottom. But that's really not necessary in particular cases. I'm going to say before we even multiply this, I see this 9 and this 3. That could be reduced. So let's deal with 3 root 6 over root 2. I just simplified this piece right here because they were nice and easy to simplify. And then I would multiply both the top and bottom by the square root of 2. And I'd get 3 square root of 6 times 2. Now, I wrote it that way on purpose, divided by 2, because the 6 times 2 is going to be 12, and it'll get big, but the 6 is really a 3 and a 2. So there's actually a pair of, and I'm going to erase this right here, this 6. I'm going to write it as 3 times, 3 times 2 times 2, like that. And now you can see the pair that's in there also, too, that would be able to escape the root. And we'd end up with 6 square root 3 over 2. And these two now can be reduced. I'm getting my rabid chihuahua-ness. Bite that thing. 3 square root 3. And that's what that one would finally turn into. Now remember, I'm not joking about this attitude. If your attitude is like, I'm going to bite the problem until I absolutely have got it finished up, you're going to be way better at this kind of concept, right? So bite your problem, figure out how to shake it down to its lowest possible values, okay? The 32 right here, I'd say it looks like it's pretty big, and maybe with it simplifying it might make it a little bit easier to rationalize before I go on further. And 32 is 16 times 2, which is a pair of 4s. You're like, yes, a pair of 4s can get out of there. And if I remove these pair of 4s, I get 7 square root 3 over, I didn't do anything to the top, a pair of 4s come out and multiply, 8 root 2. And look at that, I just made the problem way super easier. Hold on just one second. Sorry about that. The teachers were making fun of me that I finally did my recording. So I know I'm lazy. You're lazy. Everybody's lazy nowadays. All right. Now I'm going to fix this because that square root 2 is the only part down here that seems to be making us have some issues. Square root of 2, square root of 2 to rationalize this. Now upstairs, remember, radicals only multiply radicals. So I'd be dealing with 7 square root 6 divided by 8 times the square root of 4. And the square root of 4 is actually the number 2. So 7 square root 6 is 8 times 2 downstairs, or better yet, 7 square root 6 over 16. Now, a lot of people right here would make the mistake to try and simplify this radical and this downstairs component. And that's a no-no because it's an inside term is what the 6 is, and the 16 is an outside term. Remember that we don't mix cancellations or even simplifications of a radical with a whole number. They don't work that way. Insides multiply or work with insides, outsides work with outsides, okay? Now, last rabid chihuahua moment. Here we go. Let's see what we got here. Now, I'm looking at that 50 and being like, man, that's a big number. Maybe the 50 can be broken down into 25 times 2, which is a pair of 5s. And that pair of 5s is going to make it out. So I should probably simplify this guy before I do anything. The upstairs would become 5 square root 2, because that 5 is going to make it out, and 5 square root 3 down here. Now, like I just said, outsides affect outsides. Wow, these two 5s, toast. Get rid of them. That's not even really a good idea to keep those to there. But now I've made it a simple as possible problem as I could, and now I just need to rationalize the denominator, okay? Rationalizing the denominator with a multiple as the square root of 3 would give me the square root of 6 upstairs and the square root of 9 downstairs, which is going to be the square root of 6 over 3. And you can't, again, reduce that because the 6 is in the house and the 3 is not. So they don't coincide and work that way together. All right? Now check each one of those individual answers and don't beat yourself up. These particular 6 problems are about as hard as they possibly can get. You just have to have the right attitude about it. And the right attitude is, yeah, you have to do this because you're a rabid chihuahua. All right, I hope you figured that out. If you need to go back and check them again, please rewind the video and watch the actual stuff.